Hey everybody, your Friendly Math Tutor here with our video 9, the last video of our SAT one-sheet breakdown series. The PDF files for both the one-sheet and the examples from this problem are linked below. Subscribe to our channel. Check out our Facebook, Instagram, and TikTok where we've got a lot of other videos for SAT, also BC Calc, and we'll have a lot of other math videos going up there all the time. All right, so let's dive into the last section of our one-sheet. All right, so the last section of our one sheet is our last part of our formulas. We went over the good to know, the first half of these last week, and now we are going to go over the last section. So we've got the standard form of a circle, Pythagorean triples, some right triangle trigonometry, and the sum of the interior angles of an n-sided polygon. So let's start with the standard form of a circle. So here in our first example, so this, when it comes to a circle, they do give you the area and the circumference, but they do not give you this formula. So you really need to know this standard form for questions like this. So they want the radius of the circle. So what we're going to do is we're going to group the x's together and leave a space, and then group the y's together and leave a space, and keep the -9 over here where it is. And then we're going to use the completing the square method to try to get these perfect squares that are in the standard form. So the way you complete the square is you take half of 6, which is 3. 3 times 3 is 9. So I'm going to add 9 here. And then over here I'm going to do half of 8 is 4. 4 squared is 16. So then I'm going to add 9 and 16 to create my perfect squares. And then I'm also going to add 9 and 16 to the other side. So plus 9 plus 16. So x squared minus 6x plus 9 factors to x minus 3 squared. And y squared plus 8y plus 16 factors to y plus 4 squared. And then that equals -9 plus 9 is 0, so that equals 16. Now they don't ask for the center of the circle, so the left side of this problem wasn't as important. They want the right side, which is 16. That represents r squared. So therefore, r would have to be 4, the radius. Now let's take a look at another problem where we would have to use the standard form of a circle. And this one is, which of the following is the equation with center 2, -4? Well, if you use this formula, if h is 2 and k is -4, then that means you have x minus 2 squared. And then if k is -4, you have y plus 4 squared equals r squared. All right? So that means we automatically have x minus 2 and y plus 4. So we can get rid of b, and we can get rid of... does that get rid of all of them? Oh, no. That gets rid of b and d. My bad. So A and C are both possible because they have x minus 2 and y plus 4 in them. Now we got to find r. So the best way to find r is to just simply plug in the point that they give you. So we end up with 1 minus 2 squared plus, this is -12 over 5 plus 4 squared equals r squared. 1 minus 2 is -1. -1 squared is 1. -12 plus 4. So I would think of this, I'll do this over here. This is -12 plus 4. Let's think of 4 as 20 over 5. So that's going to be 8/5. And then if we square that, that's going to be 64 over 25. And then if we do 1 plus 64 over 25, well, we can see, actually, no, let's do it. So then 1 is the same as 25 over 25 plus 64 over 25. That's where we get the 89 over 25. That would have to be r squared. So therefore, we know that it's A and not C. All right, so we need to know the formula as well as how to, when you don't know r squared, you simply just plug the point in to do that. All right, let's head back to our formula sheet and let's look at the next one on Pythagorean triples. So knowing these four, 3, 4, 5, and 5, 12, 13 are definitely the most common. 7, 24, 25, and 8, 15, 17, I guess would be the next two most common. There could be others that you've seen, but these are the four that I would really know for the test. And the way that we're going to do this one, we want the perimeter of the trapezoid, so we're going to drop an altitude here. And if this is 24, then that means this is 24. So now you can see that this other side, we could do the Pythagorean theorem, but it's just easier if we know that it's 7, 24, 25, which makes this 7. And if this part's 7, 35 minus 7 is 28, so that gives us this part. So now the perimeter is just 28, 24, 35, and 25. Notice this 35 includes this 7, so I did not forget that 7. And then if we do 35 plus 25 plus 24 plus 28, that ends up giving us 112. All right, so there's a lot of different problems where just knowing the Pythagorean triples, or that it's a multiple of one of these triples, is going to save you the time of having to actually do the Pythagorean theorem. All right. So let's keep going, look at some right triangle trigonometry. So the first part of right triangle trig is simply just knowing the ratios, so knowing your SOHCAHTOA. So here, which of the following is equal to A? So first of all, I would make sure that we have A involved. So actually what I would do now, I would look at the answers. So let's see if we do tan of theta. So tan of theta is opposite over adjacent. Well, this is the opposite. This is the adjacent, and this is the hypotenuse, all based off of theta being down here. So tangent is opposite over adjacent, that's A over B. And if I want to solve for A, then if I bring the B over, that's B tan theta equals A. So that means A doesn't work. Now the next two have to do with sine, so let's see what happens if I do sine. So the sine of theta is the opposite over the hypotenuse. Well, that's the A over the C in this case. And if I get A by itself, I want to know which one's equal to A. I bring the C over and I get C sine theta equals A. Well, that rules out B, but it also tells me that C is the answer. You could check if you do the cosine. We could just do that for fun here. So the cosine of theta would be the adjacent over the hypotenuse. That's B over C. Well, that doesn't even have A in it, so it wouldn't really help us find A. All right, let's go to our other problem related to trig, and this is the second part of this. If x and y are complementary, then the sine of x equals the cosine of y. That's just something that it will really be helpful. So here, if they say sine of a over cosine of b equals 1, that means the sine of a equals the cosine of b. So we're kind of working backwards. That means if the sine of a and the cosine of b are the same, then the angles themselves must be complementary. That means that x minus 3 plus 2x plus 6 have to equal 90 degrees because of this kind of trigonometric fact, that if the sine of one is the cosine of the other, then the two angles themselves add up to 90. That's a pretty easy equation to solve. So we combine like terms, and we get 3x. Negative 3 plus 6 is positive 3, so that equals 90. And we get 3x equals, take 3 away, we get 87. And then 87 divided by 3 is 29. So answer is C. All right. Now we move to our last type, which is the sum of the interior angles of an n-sided polygon. So the sum of the interior angles of an n-sided polygon is just n minus 2 times 180. So this one's pretty straightforward. We just have to know there's 1, 2, 3, 4, 5 angles. So this is a pentagon. And the total number of degrees would just be 5 minus 2 times 180. And that is 3 times 180. And that is 540. So the sum of the interior angles of any pentagon. I know this doesn't look like the typical regular pentagon that you're used to seeing, but it has 5 sides, so it has 5 angles, so it is a pentagon, and then it must add up to 540 degrees. Okay. All right, so just to review, again, we had 2 problems with the standard form of a circle, that we have to know this equation, and the center is HK and the radius is R. Then we had a problem related to Pythagorean triples, And that is these 4. Again, there are more. You could just focus on the first 2, but knowing these save you having to do the full Pythagorean theorem. We definitely should know SOHCAHTOA and how to use that. What side is the opposite? What side is the adjacent? What side is the hypotenuse? We definitely need to know if x and y are complementary, then the sine of one equals the cosine of the other. And finally, this helps us find the sum of the interior angles of any polygon. And then if we just kind of jump back to our formula, our sheet, we went over all these part 1 strategies. Check out, that's video 1. And then part 2, common problem types, that's videos 2 and 3. And then we went over important concepts, that was videos 4 and 5. And then finally the formulas was 6 and 7 for the given on the reference sheet part. And then 8 and 9 was the good to know formulas. And that is pretty much the end of going over our SAT 1 sheet. All right, so that's the end of our 1 sheet. We have 9 videos going over 70 different examples to go over all the different problem types that are on the SAT that this 1 sheet covers. It's just a nice little cheat sheet for you to review and use while you do problems, and then just review maybe the day or 2 before. Make sure you know everything on there, and then I think that'll be really helpful when you take the SAT. All right? I hope that was helpful. Check out all the other videos. Check out our Instagram, TikTok, and Facebook for other SAT videos, calculus videos, and other math videos. I hope this was helpful, and best of luck on your SAT studies.